Hello again, and welcome back to another REPL speedrun. Today, we'll be finishing off the 2D list challenges, starting from 8.5, and ending on 8.7. If you're not so familiar about what a 2D list is, you might want to check out my previous video where we tackled challenges 8.1 to 8.4. And if you want to brush up on your list skills, I suggest you check my videos where we tackled units 7.1 to 7.c. But let's jump right in to 2D lists. So our first problem, we're given two integers, the number of rows m and columns n of an mxn 2D list, as you can see here. And this is our 2D list. And we are followed by two non-negative integers I and j. Swap the columns I and j of 2D list and print the result. Okay, so first, let's import our 2D list. First, we want to get our variables. So say parameters is equal to int I for I in range. For I in input dot split. We've seen this before. If you're not so familiar with how we input lists, you might want to check out my previous videos. And we want to import our list, or our 2D list 2D, which is int j for j in input dot split for I in range, and the number of rows is the first variable in our parameters, so it would be parameters 0. Now we want to swap these two columns. Let's actually input our columns we want to swap. So we can put this variable columns is equal to int I for I input dot split. Okay, now we have everything ready and we can start coding. So we want to loop over these lists and swap them, more or less. So what would be the best way to do this? I think the best way to do this would be to actually just print every element in our for loop with the integers swapped. That would take up the least lines of code. So we want to get each row in our 2D list. And actually we want, yeah, that's fine. And we want to get our columns in this row. And we actually want to get I column in enumerate row, right? And we want to print all the elements. So for now, let's just print column. Actually, this is element already. Element. Let's just input the sample code. And for I in input dot split. Oops, I've forgotten it here too. Okay, let's just put the sample code, and I can't spell. Oopsies. Okay, now it should be all good. So if we input this, as you can see, we just get a long list of integers. Really, I'm not too sure whether it would actually just accept this as output. We could try. But I would also rather format it so it looks like this nice grid over here. So how are we going to do that? We're actually just going to set a variable here, call it row string, up here to empty. And every time we get an element over here, we want to just add it to the row string. So row string plus equals just adding it to the end of the row, more or less. Plus equals the string of, and actually we just don't need to convert this to integers at all. So we can just put element directly. And finally, once we've finished looping over the entire row, we can print the entire row string. So let's see if that worked. And oops, we forgot to add spaces. So we want to add an element and we also want to add a space. And finally, we if we run this code, it's going to give a space over here at the very end of the string, and we want to remove that. So finally, we can have row string. Let's just slice off the last character over here. So we can slice it right there. Okay. And as you can see, there's no more space on the end of the strings. Okay, it's cool. Now the last thing we have to do is actually swap the two columns that we want to. So to do that, we want to check if this I, which represents the column index, is actually one of the columns we want to swap. So if I in columns how do we want to implement this? Let's just say if I equals columns 0, then element is equal to row columns 1. So what this does is if our current column is the first column we want to swap, we're just going to set this element, which is a placeholder variable, to whatever element is in the other column. So say this is one of the columns, we want to swap. It's going to get the element in the other column, and it's going to print this in this place instead, so it will swap them successfully. And we want to repeat the exact same thing. If I equals columns 1, element equals row columns 0. And so there's probably a more efficient way to do it than this, by combining both the if and elif statements. But for readability, I think it's nice to see what we can do there. So if we now print this code, we can see it swaps the elements in the list. And so if we submit this code, it should work perfectly. Right, let's move on to the next challenge. Snowflake. Given an odd positive integer, produce a two-dimensional array. Fill each element with the character dot. Then fill the middle row, the middle column, and the diagonals with the character asterisk. And we will get the image of a snowflake. And we want to print the snowflake in n times n rows and columns and separate the characters with a single space. Okay, sounds good. So we can have our size of the snowflake is equal to the input. And we want to create, we want to iterate 2 times over the size. So let's say this is the row again, going down vertically is the row, and going horizontally is the column. So for row in range size, for column in range size, and we actually, similar to the previous challenge, we want to create an empty string at the start of the row, which we can print later. And okay, so for column and range size, we want to check, well, let's just print a dot right now. So row string plus equals dot with a space at the end, and then finally row string. We should print the row string with the last element sliced off, so we remove the final space. If we run this, put 7, it's going to give us 7 dots. So as you can see, no space at the end, looks like a perfect square, looks exactly like the output, except there are no stars. So we need to check if our current position is somewhere where we should be putting a star instead of a dot. So we we'll do this using an if statement, and the else will be, if this if statement is true, let's put a star. Otherwise, let's put a dot in its position. How do we know if it should be a star? Well, we need to fill the middle row, middle column, and the diagonals with the character asterisk. Okay. So first, let's check if it's the middle row. If it's the middle row, then row plus 1 divided by 2, I believe, is the middle. So if size plus 1 divided by 2, I believe, equals row, then we get the middle column as all stars. And if we print this, put 7. Oh, oopsies. Row string, forgot to put plus equals here. Row string plus equals. And if we put 7, oh, that's 1 too low actually. It should be size minus 1, I think. Size minus 1 divided by 2, and that is correct. So as you can see, that gets the middle row. The middle column will be the exact same format. Is instead of comparing this to row, we want to compare it to the column. So if we run this code again, then as you can see, the row and the column are in the X position. Now finally, we want to check whether whether the cell is part of either of the diagonals. So we know that if the character we're currently on is part of this diagonal, then row equals column. So we can just put that in. And if you're not sure why, let's just check. Okay, this star over here is at the index of 1 in the row and the index of 1 in the column. This star here is at the index of 0, 1, 2, 3, 4 in the row. So if the row equals the column, it's the we also want to put a star and also the anti-diagonal. So if you remember from the anti-diagonal challenge, a star is on the anti-diagonal if the row plus the column is equal to the size minus 1. So if row plus column equals size minus 1, it should be put on the anti-diagonal. So if we run this code, put 7, as you can see, we have our snowflake. And that's all there is to it. If we put like something like 15, it will print a bigger snowflake. Notice if we put a like an even number, oh, I didn't know that. Oh, it must be using integer division. That's why I would have expected this to error out, but I guess it's using integer division. So it actually prints quite a nice design too. So if we submit this code, as you can see, it passes all the tests. So finally, we have our last 2D list challenge, chessboard. Given 2 positive integers, create a 2-dimensional array of size nxm and populate it with characters. The full stop and the asterisk in a checkered pattern. The top left corner should have character full stop. Okay, so we want 2 characters, so we can say our parameters. Actually, I think, no, let's leave it like this, not get too complicated. So we know that this top left corner is a dot, and we're going to do the exact same thing over here as the previous challenge by looping over the range in parameters. So for row in range, parameter 0, for column in range, parameters 1, and this will give us a grid. For now, let's, as like before, let's make a row string, make it empty, and say here, let's add a dot and a space to it, and we want to print the row string with the last character sliced off. Okay, so if we run this code and put like 5, 6, as you can see, we have a grid of dots that's 5 tall and 6 wide. That is 5 rows and 6 columns. Now we just want to alternate this pattern actually. And how do we do that? We want to find a relationship between the row and the column and whether it should be a dot or an asterisk. And if you want to figure out, maybe pause the video right now, but for those of you who just want to know the answer is if the sum of the row and the column is divisible by 2, it means that it should be a dot. And if the sum of the row and the column is not divisible by 2, in other words, it's odd, it should be an asterisk. And let's check that. So over here, index is 0, 0, 0 plus 0, 0, divisible by 2. This index over here, maybe, this is 0, 1, 2, 0, 1, 2, 3, 4. 2 plus 4 equals 6. 6 is divisible by 2. Now let's try for a star. 0, 1, 0, 1, 2, 3, 4. 1 plus 4 is 5. It's not divisible by 2, so it must be an asterisk. Right. So we can then simply check if row plus column modulo 2 is equal to 0, then row we want to add the dot to it. Otherwise, we want to add the star to it. And this should work. So if we put our example parameters in, as you can see, it prints a checkerboard that looks exactly identical here. So as you can see, this code works. And that's the end of the 2D list challenges. I hope you enjoyed these challenges, and next time we will be moving on to Unit 9, which I believe is sets. So you might want to pull out your Venn diagrams and some graphing paper. See you then.